the first session, it is very true that before going for different methods, before going for different applications, we should first of all cover introduction to optimization. What is optimization? Where it is applicable? How we can formulate the problem? What are the different parts of the problem? So these are the things which we should know first. So let's begin with introduction to optimization. Let's define optimization. We'll begin with a funny definition just to create an interest in optimization. What is optimization? Just read this definition. Optimization is the art of giving bad answers to the problems. So if we say that this is the definition given to optimization, it is the art of giving bad answers to the problems. One can think that why at all then we are, the organizers have organized an STTP on optimization, and why at all we have joined this STTP if it is an art of giving bad answers to the problems. But as I said, this is funny definition just to create interest in optimization. And if you observe it carefully, you will find that there is a comma at the end, which indicates that the sentence is not yet completed. Something more is expected to come. Let's see what that is, and then the definition will be complete. For which otherwise worst answers are given. Now we will read the definition completely. Optimization is the art of giving bad answers to the problems for which otherwise worst answers are given. Now the definition is complete. It is the very famous quote or very famous definition given by a very giant personality in the field of operations research, T.L. Sati, given in 1958. Now just give a thought over this definition. Let's say that you have got a problem in hand. You have a problem and you have to answer this problem. You have to find the solution to the problem. You are bound to find the solution. You cannot go away from the problem. You cannot escape from the problem. You are having a problem. You are working in a company. You are working in an institute, and you have come across a problem. You have to find the solution to the problem. You have to give solution to the problem. And then you will think of different possible solutions. Let's say that you come across a situation that for a particular problem, you have two solutions only. One of them is a worst solution and the other is bad solution. There is no any other solution. You have two solutions only. One is worst and other is bad. And if it is said by the management, by the organization, the authorities, that you have to give answer. Answer is to be given to that particular problem because the problem is to be solved. So then if you have two answers, one is bad, other is worst, definitely you will be selecting the bad answer. Why? Why? Because you have two answers and the other is worst. So if you think over it, what you did actually, you actually found out the best possible answer. You found out the best possible answer, which is actually bad answer because there is no other answer. So we can say that actually optimization is the art of finding the best solution under given circumstances. We will come to this definition also afterwards, and we will see what is the meaning of circumstances and all that. But then basically it is the art of giving the best answer, finding the best solution. And when we say that it is the art of giving the best solution, finding the best solution, definitely we are sure that we have more than one solutions, more than one answers. I'll give an example. If you are starting from your residence and you have to come to your college, आपको घर से निकल के आपके कॉलेज तक आना है, and there is one and only one way, there is one and only one path which takes you from your residence to your college. You do not have any other path available. Can you think of which route I should follow? No, there is no meaning in thinking about this question. I'll say that this is useless question, hopeless question. If you have only one route, you have to follow that. Absolutely no meaning in thinking that which route I should follow. भाई एक ही रास्ता है तो उसी रास्ते से जाना पड़ेगा ना, दूसरा रास्ता है नहीं, क्या करेंगे? So What I said, that optimization comes into picture only when you have more than one possible solutions. If you have one and only one solution, there is absolutely no question of optimization. Okay, let's proceed. What is the motivation? There are two things, motivation and inspiration. What motivates us to study about optimization? What inspires us to study about optimization, to go for optimization? What is the motivation? Motivation is to minimize the effort required, to minimize the money required, to minimize the manpower required, to minimize the material required, to minimize the losses. So this is one of the motivation. Or the other that can motivate us to study this particular subject is to maximize the profit, to maximize the desired profit, to maximize the benefit, to maximize the output, to maximize the efficiency. That is the motivation. Basically, whenever you are trying or you are thinking to minimize something or maximize something, it is an example of optimization. In between, you will find and/or, which indicates that sometimes we are interested in minimizing something only. Sometimes we are interested in maximizing something only. But sometimes we are interested in minimizing something and at the same time maximizing something. Okay. The construction of road is going on in between Badnera and Murtijapur. You must have gone through the news. What they are doing, they are trying to minimize the time required to construct the road from Murtijapur to Badnera or Badnera to Murtijapur. And at the same time, they are taking care that the strength of the road should be maximum. Road बना देना है तो कैसा भी बना के नहीं चलेगा. So there it is a multi-objective task. Multi-objective task, and it is an optimization problem. Trying to minimize the time required to complete the construction of road between Badnera and Murtijapur, and at the same time trying to maximize the strength of the road. So sometimes it may be a multi-objective problem where you try to minimize something and simultaneously you try to minimize something, minimize and maximize. Or it is possible that you are interested sometimes in minimizing something only, or maybe interested in maximizing something only. So that is basically the motivation. You try to minimize something or maximize something depending upon what that thing is. If it is profit, definitely one will try to maximize. If it is loss, definitely one will try to minimize it. So that is the motivation behind studying optimization. Let's see the examples, and that will make it clear that what inspires us to study optimization. Basically, study of optimization is inspired from nature. Study of optimization is inspired from nature, and that is why you will find that nowadays there are so many nature-inspired algorithms are coming, which are used to solve the optimization problem. Genetic algorithm, particle swarm optimization, firefly algorithm, gravitational search algorithm, owl search algorithm, fox algorithm, and so on and so forth. Ant colony optimization. There are so many things, so many nature-inspired algorithms. So basically, to study optimization, we are inspired from nature. Let's see a few examples from nature. In metals and alloys, the atoms take the position of least energy to form a unit cell. We do not have to do anything for that. Automatically, the atoms of metals and alloys, they acquire the position. They try to take the position so that position of least energy to form a unit cell. If you see the birds forming nests, they will try to do two things, multi-objective optimization. You will see that they will pick up some sticks, they will pick up some feathers. They try to maximize the strength and comfort, both. maximizing two things, trying to maximize the strength as well as trying to maximize the comfort. So this is an example of optimization from nature. If you think about the most compact housing society means maximum population in minimum area. Two things come to our mind. One is ant colony and the other is honeycomb structure. Madhumakhi ka chhatta. The honeycomb structure. Maximum population in minimum possible area. Multi-objective optimization. The honeycomb structure is one of the most compact packaging arrangement. So this gives an idea that optimization is inspired from nature. And actually, it is the subject, it is the course for which we are performing experiments since our childhood. Since our childhood, we have performed so many hundreds of experiments of optimization. Unknowingly, we do not know that we have performed the experiments of optimization, but unknowingly, we have performed hundreds of experiments on optimization. So I say, in my opinion, actually, optimization is the subject in which we have already performed hundreds or thousands of experiments already performed, and now we have got a chance to study theory behind that. Otherwise, what we do, that we are being taught the theory first. Say, if we take the example of superposition theorem, what do? We teach superposition theorem in the class, and then we take the students in the laboratory to verify superposition theorem. What I mean is, first of all, we teach the theory, and then we take the students to verify the theorem, verify the algorithm, or whatever it is. But then in case of optimization, the thing is reversed. It is opposite. We first perform the experiment, or rather we have already performed the experiments. I will now give you two examples which will make you realize that yes, you have also performed the experiments. See, and these two examples I used to give every time whenever I get a chance to speak on optimization. I definitely give these two examples. Say, in the morning hours, I am habitual of taking a cup of tea. मुझे चाय लगती है सवेरे, एक कप चाय पीता हूँ. So I am habitual of taking a cup of tea, and I am habitual of going through the headlines of newspaper, because I cannot go through the newspaper completely due to the morning hurry. I have to come to college on time, so I go through the headlines of newspaper. Now, it takes 5 minutes for me to take a cup of tea, and it takes 10 minutes for me to go through the headlines of newspaper. If I take a cup of tea and then I go through the headlines of newspaper, how much time will be required to complete the two activities? 5 minutes for taking a cup of tea and 10 minutes for going through the headlines. Total 15 minutes. If I do the jobs in reverse way, that is, go through the headlines of newspaper and then enjoy a cup of tea, still 10 plus 5, total 15 minutes required. What do I do? Or what do many of us do? We enjoy a cup of tea and simultaneously we go through the headlines of newspaper. What is happening with this? What is happening with this? We are able, or rather I'll say I am able to complete the two jobs in 10 minutes, which otherwise would have taken 15 minutes. 5 plus 10, instead of that, I need only 10 minutes now. So if I put in proper words, what I did, I minimized the time required to complete two activities. And as I said, the moment minimization or maximization comes, it is an example of optimization. So I have performed the experiment. Every morning I am performing that experiment of optimization, taking a cup of tea and simultaneously going through the headlines of newspaper. Let's think of another example. Those who have enjoyed cooking, खाना बनाने की जिसने आनंद लिया है वो इसको महसूस कर सकेंगे. What do we do if we are cooking? We put pressure cooker. We put pressure cooker for with dal and rice on one gas stove, and on the other gas stove simultaneously we put a kadai for vegetable cooking, and simultaneously we are utilizing the third gas stove for making chapatis. Why we are doing this, or why somebody is doing this type of thing at our home? Because he or she is trying to minimize the time required. Otherwise, let's complete the job of pressure cooker and then go for cooking vegetable and then go for making chapatis. It may take, let's say, 1 hour time. Instead of 1 hour, all three things we can finish within 20-25 minutes. So what we are doing nowadays, people are going for 4-burner shegdi, 4-burner gas stove, 5-burner gas stove, and so on. Why? Optimization, trying to minimize something, trying to minimize the time required, So this way, if you think, every now and then, when we go for online shopping, I want to purchase a refrigerator. If I go through online, or let's talk about offline, I do not go to a particular shop directly and purchase refrigerator. मुझे फ्रीज खरीदना है, I go to this shop, say X brand, then Y brand, then Z brand. For Z brand, I then go to shopkeeper 1, shopkeeper 2, shopkeeper 3. Why? Because I think that I should get a good refrigerator in minimum amount. I am trying to minimize the money required to be paid. That is an experiment of optimization.
Hello, Bedekar sir. Hello, Bedekar sir.
Let's take some other example.
Sir, I think in meanwhile your voice was not audible.
Okay.
Just for 10 seconds.
Okay. Okay, I'm just checking my net connectivity. I'll just check and we'll come back.
Now it is audible, sir.
It is audible? Okay.
Yeah,
fine.
now it is audible.
Fine. Okay, let's take another example. What time do we get up, or let's say what time do I get up in the morning so that I can maximize the amount of sleep, still make it to work on time, that is to reach to college on time. Optimization, what I am trying to do, trying to maximize the amount of sleep with a limitation, with a restriction that I should reach my workplace, my college on time. So this restriction, limitation is called constraint. Is called constraint in terms of optimization. We'll come to that afterwards. But then this is also an example of optimization. Which is the best route to college? I was talking about this earlier also. And there only I have made it clear that optimization comes into picture when you have 2 or more than 2 possible answers. With one answer only available, you cannot think about optimization. If you have 3 routes leading you from your residence to college, you can think of the best route. And even then, the best route will be decided by what is your objective. Your aim is to start from residence and to reach to college, but the objective may be different. Objective may be to reach to college in minimum time. That may be one objective. Maybe objective for me. to start from residence and to reach to college in minimum time. Somebody else, a young chap, purchased a new bike, may think of, say, riding the bike with zigzag driving. मजा करेंगे जरा. So try to choose the route in which there is maximum opposition. Opposition means maximum traffic, so that I can enjoy zigzag driving. इधर उधर घुसा के चला सकूंगा. So objective is different. Aim is to start from residence to reach to college. Or a person like me, who is from village background, never seen flyovers. So if flyover comes to my path, I become very happy. So I'll choose the route such that there will be maximum number of flyovers in my path. And accordingly, the solutions may be different. Anyway, basic thing is, I have got more than one solutions, then only I am thinking about optimization. Which book should I use? Which book should I use? The objective may be such that I will score at least 40 marks in XYZ subject. The answer will be different. See, I am trying to say achieve at least 40 marks. Optimization aa gaya. Or which book I should, so that I can score as maximum as possible in XYZ subject or course. Trying to maximize the marks scored. As I'm trying to maximize the marks scored, my answer may be different. So I have quoted these examples just to make you realize that yes, optimization is everywhere. It has so much impact on our life. Every now and then we are performing, and everybody is performing the experiments of optimization. Let's see some technical examples. Find the dimensions of a cold drink can, cylindrical cold drink can, with top and bottom to maximize its volume, given that the total surface area is equal to 24 pi. What does it mean? It means that the material that is made available is fixed. The sheet that is available to make the cold drink can, including top and bottom, is having an area of 24 pi. With that given sheet of material, metal, you have to design the cold drink can such that the volume will be maximum. Trying to maximize optimization. Using the given data, design a three-phase induction motor for maximum efficiency. Okay, those who have taught electrical machine design, they must have come across this thing. Trying to maximize the efficiency. Or the aim is to design a three-phase induction motor. The objective may be different. Objective is to maximize the efficiency. Somebody else may have the same aim with a different objective. Aim is to design a three-phase induction motor, and objective is such that the motor should have weight as minimum as possible. So design a three-phase induction motor for minimum weight, or design a three-phase induction motor for maximum power factor. So whenever basically think of the word minimum or maximum comes in the problem, it is optimization problem. Definitely it is optimization problem. We can say that this is the vision of optimization. Nowadays we are very habitual of vision and mission. Because of NBA and NAC, we are all very much habitual of writing vision and mission. What is vision of optimization? Striving towards excellence. Striving towards excellence. Trying to find the best solution. Trying to find the best answer. That is the logo or vision statement of optimization. Now let's see technical definition of optimization. We started with, as I said, funny definition. It is the art of giving bad answers to the problems for which otherwise worst answers are given. And when we thought about that, we found that actually what we did there also, when while choosing the bad answer, what actually we did, we tried to find out the best solution. So optimization is an act of obtaining the best result under given circumstances. Finding the best result under given circumstances. Okay. So these circumstances, they put some limitation, they put some restriction, and those restrictions, limitations, they are called constraints in the language of optimization. And in the practical situation, when we work in the field, whether it is college and educational institution or it is an industry, company, irrespective of that, when we come to practical situation, definitely we come across some limitations, some restrictions. We do not have a problem without any restriction. There are very rare problems in which there is no restriction. There is a problem and it is said that there is no restriction, you just give the solution. Very rarely we come across this type of situation. Almost always we have some limitation, restriction, circumstances. They are called constraints. Let's see another technical definition. Optimization is the process of maximizing or minimizing a desired objective function while satisfying the prevailing constraints. So when we see this definition, with this definition, we can slowly proceed to the parts of optimization problem. There will be a part which will be called as objective function. There will be a part which will be known as constraints. Okay. So optimization is the process of maximizing or minimizing a desired objective function while satisfying the prevailing constraints. Whether the objective function is to be maximized or minimized depends upon what that objective function is representing. If it is representing, say, efficiency of a machine, definitely we will try to maximize. If I have written an objective function which is representing the transmission loss, definitely I will try to minimize. So it depends that what that objective function is representing, whether minimum, whether it is representing a thing which is to be minimized or to be maximized. Accordingly, we decide. And we have to choose a solution keeping in mind that the constraints, the limitations, the restrictions must be satisfied. Otherwise, the answer is said to be a non-feasible solution. Non-feasible solution. Feasible solution means a solution that satisfies all the constraints, and non-feasible solution means a solution that does not satisfy at least one constraint. It is violating at least one constraint. In any engineering system or even in general day-to-day work, the engineers or the managers have to take many technological and managerial decisions. Even if you are working, even if we are working as a teacher, we have to take many technical decisions and we have to take many decisions from the organization point of view. Managerial decisions. Say you are being given the charge of annual social gathering of the college. You have to take managerial decisions. So an engineer, irrespective of where he or she is working, have to take many technological and managerial decisions, and the ultimate goal, the ultimate aim of all such decisions is to minimize something or to maximize something. To minimize something or to maximize something. Say, for example, if I am being made in charge in an annual social gathering, I am being made in charge of, say, singing night. What I will do, I'll put a selection trial and I'll select the number of songs so that number of participants so that the activity can be completed in 1 hour. So I have to take a decision. And what is the goal of decision? To minimize the number of participants such that, or you can say maximize. Maximize. ज़्यादा से ज़्यादा बच्चों को chance देना है. So maximize the number of participants, but subject to constraint that the event should be completed in 1 hour. So whenever you take a decision, whether it is a technical decision or general decision, the ultimate goal of all such decisions is to minimize something or to maximize something. And minimizing or maximizing something means you are dealing with optimization. Definitely, you are working on optimization. With this background, we can now proceed for the parts of an optimization problem. Because see, what is most important when we see optimization on, or when we think about optimization to be applied to our problem, may it be MTech dissertation problem, may it be PhD thesis problem, or may it be some other problem, we have to, if we want to solve it systematically, we have to formulate the problem properly. We have to formulate the problem properly. And to formulate the problem, we should know what are the different parts of the problem. How the parts are written, how the problem is written, then only we will be able to formulate the problem. So for that, it becomes necessary. See, nowadays, you need not study the methods. आपको बहुत से मेथड पढ़ने की जरूरत ही नहीं आजकल, because everything you can do with the help of programming. There are so many things available, so many software packages available. A very common and very well known software package as well as language, which is a combination of language and package, that is MATLAB. You can solve the problem in minutes, or sometimes in seconds with the help of MATLAB. The only thing is that you should formulate your problem properly. So what is more important is not understanding a method and getting the solution. Rather, more important thing is to formulate the problem properly, to understand the problem and formulate it properly. Once the problem formulation is done, solution can be obtained using different methods, using different softwares, and you can compare the solutions also. And for formulation of the problem, we must know the parts of an optimization problem. With the parts, we will then proceed. After studying the parts, we will then proceed for formulation of problem, which will lead us to know about the two broad categories. There can be n number of categories, but there are two broad categories of optimization problem. Let's see the parts of optimization problem. The first part is design vector. Its elements are called design variables. Second part is called the objective function. So first of all, we have to decide the design vector. That is, we have to decide the variables. Then we have to proceed for objective function. With the help of design variables, we will write a mathematical function, and that mathematical function basically we will try to minimize or we will try to maximize. That is objective function. And the third part is constraints, limitations, restrictions. There are different ways of categorizing the constraint. One is called hard constraint and soft constraint. Hard constraint and soft constraint, एक इसका example देता हूँ मैं, but I'll restrict myself because of the time restriction. I'll give you a technical example. If you are trying to design a three-phase induction motor, and it is said that design a three-phase induction motor for 440 volt 50 hertz. I mean, the input given to the motor will be, the input voltage will be 440 volts line to line. Frequency of input supply is 50 hertz. Out of this, we being electrical engineer, we know that voltage constraint is a soft constraint. If it is 440 volts and finally if I find after designing the motor, if I recalculate that what will be the what should for this with these parameters, what should be the input voltage line to line. If I get 445, I say that okay, my design is fine, no problem. It was asked to design for 440 volts input. I have designed and I got that it will work properly on 445 volts. Doesn't matter. Voltage constant is a soft constant. But then what about frequency? I have to design the motor for 50 hertz. After design, once the design is completed, we have to do the calculations and check whether the input given is satisfied with this design or not. So when we see that no, this is working properly on 52 hertz, we will reject that design. 52 hertz will not do, no. Because the frequency constant is a hard constant, rigid constant. 50 means 50. Voltage is soft. Okay, 440 volts chalega, 445 chalega, 435 chalega, no problem. So that is hard and soft constant. We are not interested much in this category of constant. There are many more categories of constants, but what we are interested more is in equality and inequality constant. The constant or the limitation or the restriction in which we have equal to symbol is called equality constant, and the constant in which we have inequality, less than equal to or greater than equal to, that is called inequality constant. In optimization problem, generally, almost always I will say, we never come across a situation where we have less than type of constraint or greater than type of constraint. If it is less than, it will always be less than or equal to. It will not be only less than. Likewise, whenever it is greater than, it will be greater than or equal to. I mean, you start from the boundary and then you go ahead. Or you start from the boundary and you come to lower side. So that boundary is must. And that is why we do not have a constraint of less than only or greater than only. If it is less than, it will be less than equal to. If it is greater than, it will be greater than equal to. So less than equal to and greater than equal to, these constraints are called inequality constraints. And if we have only equality equal to, that is called equality constraint. So these are the parts of optimization problem. We should formulate a problem such that it should look like this. We should formulate a problem such that it should look like this. When we read the problem, it should be like this. Find this, so as to minimize this, subject to this. That is, find the value of design variable, which will minimize or maximize the objective function under the given constraint, satisfying the given constraint. Mathematically, it is written as find capital X, which is representing design vector, equal to x1, x2, x3 up to xn, that is n number of design variables, so as to minimize fx. It may be maximized depending upon what that function is representing, so as to minimize fx, subject to gjx greater than equal to 0. Greater than equal to 0 is actually symbolic representation of inequality constraint. It is not necessary that all the times we should have greater than equal to 0. We can have less than equal to type of constraints also. So m number of inequality constraint, p number of equality constraints, and n number of variables. Purposefully, I have taken x1 to xn, then j is equal to 1 to m and j is equal to 1 to p, to make it clear that there is absolutely no relationship between number of variables, number of inequality constraints, and number of equality constraints. You can have 3 design variables, 2 inequality constraint and 2 equality constraint. Or you can have a problem in which you have 5 design variables and there are 4 inequality constraint and there is no any equality constraint. Equality constraint hai nahi problem mein, chalega, no problem, no issue. Or you can have, say, 3 equality constraints and there is no inequality constraint. Doesn't matter. So this is in general the way in which we should be able to write our problem mathematically. Then only we can proceed for applying some method and getting the solution to our problem. So we should be able to formulate our problem. That is the most important and that is the most difficult task, to put your problem in this fashion. Once this is done, the remaining part is very easy. Getting solutions, say, as I said, that nowadays we have software, Scilab is there, MATLAB is there, and many more things. We can get the solution very easily. What is important is whether we can formulate the problem. The most important thing and most difficult thing, I will say, is to formulate the problem. Okay. It is to be formulated like this, and once it is formulated in this fashion, you can proceed for getting the solution. Let's see the formulation, 2-3 examples on formulation. ABC, why I am taking these problems? Because it will make how to formulate the problem. It will make it clear, and at the same time, I am trying to make the categories of the problem clear. 2 broad categories. Okay. The ABC company during festival season combines 2 items A and B to form a gift pack. Given that the gift pack should not weigh more than 5 kg. Also, at least 2 kg of A should be used and not more than 4 kg of B should be used. So they are all limitations. ये सारे restrictions है, circumstances. The gift packet should not weigh more than 5 kg. The gift packet should contain at least 2 kg of item A, and the gift packet cannot contain more than 4 kg of item B. Then the net profit contribution to the company is rupees 5 per kg of item A and rupees 6 per kg of item B. Find the proper mix to maximize the profit. I mean, we will not think here that company is giving gift packet, so how company will earn profit? It is indirect profit. Company used to give gifts. When company is giving gift, doesn't mean that actually company is paying from the company's pocket. No, it is paying from customer's pocket only. But it is a way to, say, improve the sales. So a company is planning to give gift packet. Let's formulate this problem. We'll proceed little bit fast. See, there are 2 items to be used, item A and item B. So I'll first of all think of my design variables. What I have to do? I have to find out the proper mix. Proper mix means I have to find out how much kg of item A I should take and how much kg of item B I should take. So I am taking x1 kg of item A and x2 kg of item B. So what I have to do? I have to find out x1, x2. I have got my design variables. Now objective function. If I read the problem completely once, twice, thrice, again and again, I come to know that my objective is to maximize the profit. My objective is to maximize the profit. So I should write a mathematical function in terms of x1 and x2 so that it will represent profit. So it is given that the profit contribution is 5 rupees per kg of item A and 6 rupees per kg of item B. I am taking x1 kg of item A. So per packet profit because of item A will be 5 times x1. And because of item B, it will be 6 times x2. So what will be the total profit per packet? It will be 5x1 plus 6x2. Total profit will be 5x1 plus 6x2. And that is what I have to maximize. So second part. First part, design variables decided. Second part, objective function, mathematical function, written with the help of design variables. which is to be maximized as per the problem given. Now I will come to part number 3. The constraints, the limitations, the restrictions to be written now. If I read the problem, it says that the gift packet should not weigh more than 5 kg. And as per my thinking, my assumption, I am taking x1 kg of A and x2 kg of B to form the gift packet. So what will be the weight of gift packet as per my assumption? X1 plus x2. And this x1 plus x2 should not weigh more than 5 kg. So it can weigh at the most 5 kg. Hence, x1 plus x2 should be less than or equal to 5. This is first constraint, inequality constraint. Then I read the problem, I find that at least 2 kg of A should be used. At least 2 kg of A is to be used. How much kg of A I am using? X1. X1 kg of A I am using. And I have to use minimum 2 kg of A. So this X1 has to be greater than or equal to 2. X1 has to be greater than or equal to 2. On the other hand, it is said that not more than 4 kg of B, not more than 4 kg of B should be used. And how much I am using? X2. So X2 has to be less than or equal to 4. X2 has to be less than or equal to 4. Now, if I read the problem, I can say that yes, I have taken everything into account. I have formulated the problem as per the problem structure. जो ढांचे में मुझे problem चाहिए था, I have formulated the problem in that particular fashion. Find x1, x2 so as to maximize 5x1 plus 6x2 subject to x1 plus x2 less than equal to 5, x1 greater than equal to 2, x2 less than equal to 4. Apart from this, in any engineering problem, in almost all engineering problems, we come across a situation that the design vectors follow the non-negativity constraint. Design variables follow the non-negativity constraints. Non-negativity constraint means what? The design variables cannot take negative, cannot take negative value. They cannot take negative. They should not take negative value. In this problem only, if you think, can I take minus 1 kg of item A, minus 2 kg of item B? No, not possible. Negative weight, we cannot. So, finally, we write a constraint. Of course, it is not given in the problem, which is called non-negativity constraint. It is written as x1, x2 greater than equal to 0. Now, with this example, we will come to the categories of optimization problem, types of optimization problem. There are different ways. If you go through the book, most common books, most widely used book for optimization or operations research is Engineering Optimization Theory and Practice by S.S. Rao, or maybe Operations Research by Gupta and Hira Gupta, or Operations Research by J.K. Sharma or Hamdi Taha. So these are the most popular books on optimization or operations research. You will find that in these books, there are different methods of categorizing the optimization problem is given. Different methods are given. In one way, you can categorize in this way. In other way, you can categorize like this. But we will see two broad categories. Linear problem and non-linear problem. A linear optimization problem and a non-linear optimization problem. So here we will see a particular type, that is linear optimization problem, which is called linear programming problem. It's called linear programming problem. What is linear optimization problem? A problem in which each and every term of objective function and each and every term of constraint is linear. each and every term of objective function and each and every term of each and every constraint is linear, then the problem is said to be a linear programming problem or linear optimization problem. So here you can see first term of objective function 5x1 linear, 6x2 linear. Likewise objective function x1 linear, x2 linear. So you can see and you can decide that this problem is a linear optimization problem, linear programming problem. Linear programming problem means linear optimization problem. If you have a single term, let's say that objective function and constraint मिला के आपके 100 terms है, and in those 100 terms 99 terms are linear, but there is one term which is non-linear. That single non-linear term will make entire problem to be called as non-linear optimization problem. एक भी term non-linear हो गई तो problem हो गया non-linear. It is not linear. So long as all terms are linear, the problem remains linear. A single non-linear terms makes it non-linear. Non-linear means what? If you have x1 multiplied by x2, if you have x1 square, or if you have x2 cube, or if you have sine of x1, or if you have log of x2, any term like this will make the problem non-linear optimization problem or non-linear programming problem. So this particular example is taken to tell you that the first category is linear optimization problem and what is the meaning of linear optimization problem. There are n number of methods available to solve linear programming problem. Starting from graphical method, you have simplex method, two-phase simplex method, big M simplex method, revised simplex method, dual simplex method, and so on. Many number of methods available to solve linear programming problem. And for a particular type of linear programming problem, there are typical methods available. For example, transportation problem is a linear programming problem. But transportation problem, looking at its number of variables and constraints, is never solved by simplex or two-phase or big M or revised or dual simplex like that. Transportation problem, we have typical separate methods available. Northwest corner method, least cost method, Vogel's approximation method. These are the methods which are used to find the initial basic feasible solutions to the problems. STTP selectors. So these are the methods which are used to solve transportation problem. If you want to find optimum solution to the transportation problem, you have to go for stepping stone method, or you have to go for say modified distribution method. Likewise, assignment problem. Assignment problem is another typical example of linear programming problem. Assignment problem is linear problem. You can take an example. I'll take an example which will make you clear what is assignment problem. अभी मैं कह सकता हूँ कि if there are 7 subjects in the department to be taught and there are 7 teachers who are available, then which subject should be assigned to which teacher? That is an assignment problem. Linear problem है, but it is a typical problem. It cannot, it is never solved using simplex or whatever methods I have listed. There is a typical critical separate method, special method, Hungarian method, which is used to solve the assignment problem. So there are many more methods available for different type of problems. Now coming to the next category, let's take this problem. In a submarine telegraph cable, the speed of signaling varies as changes as or is proportional to x square log to the base e 1 upon x, where x is the ratio of radius of the core to that of the covering. We have to find the ratio x such that the greatest speed of signaling is achieved. Greatest speed of signaling is achieved. This is the problem. So for this particular problem, when I formulate the problem, I find that there is no constraint. If I read the problem, what I have to do, I have to find out x. Find x. If I write the problem, it will be find x, so as to maximize k multiplied by x square log to the base e 1 by x. What is that k? K is constant of proportionality. It is constant because speed of signaling is proportional to x square log to the base e 1 by x. If it is like that, find x so as to maximize x square k into x square log to the base e 1 by x. I read the problem again and again and again. I find that there is no limitation, no restriction is given. So I say that it is an unconstrained optimization problem. And when I was thinking about the two broad categories, linear and non-linear, this problem is non-linear optimization problem because the objective function is non-linear. X square term आ गया, log का term आ गया, उसमें भी 1 by x आ गया, so lot of non-linearity. So and multiplication है फिर उधर x square multiplied by log to the base e 1 upon x. So the problem is non-linear. Non-linear and there is no constraint, so we say that it is unconstrained non-linear optimization problem. So if the problem is a non-linear optimization problem, which is unconstrained optimization problem, unconstrained non-linear optimization problem, again we have n number of methods available. Fibonacci search method, golden section method, steepest descent method, conjugate gradient method, Newton's method, quasi-Newton method, and ... means the list is long. There are many number of methods available. Okay. Coming to the next, find the next category. Find the dimensions of a cold drink can with top and bottom to maximize its volume such that the total surface area is equal to 24 pi. We have seen this example earlier. Now let's formulate. What I want to do, I want to design a cold drink can, cylindrical cold drink can. Cylindrical word यहाँ पे छूट गया है. A cylindrical word is missing. It should have been there. So what I want to do, I want to design a cylindrical cold drink can. So I can say simply, I want to design a cylinder. I want to design a cylindrical shape. And when I say that I want to design a cylindrical shape, what I have to do, what I have to find out, I have to find out the radius of the base and the height of the cylinder. These are the two dimensions. They are sufficient to design a cold drink can if it is perfectly cylinder. Okay. So what will be my design variables? I'll have two design variables. I can call the design variables as x1 and x2, or I can call the design variables as r and h. R is representing radius, h is representing height of the cylinder. So I have two design variables. Find r, h. First part done, design variables written. Now I will think about the objective function. What I have to do, what is my objective? I want to maximize the volume. Maximize the volume. Volume of what? Volume of the cold drink can, which is cylindrical in shape. So basically, I want to maximize the volume of a cylinder. I want to maximize the volume of a cylinder. So what I will say, objective function will be so as to maximize V is equal to pi r square h. Pi r square h is the volume of the cylinder. So as to maximize V is equal to pi r square h. Now, is there any limitation? Yes. The restriction is there. I have been given a sheet of metal of fixed size. The area of that sheet which have been given to me is 24 pi. So there is a constraint subject to 2 pi RH plus pi r square is equal to 24 pi. 2 pi RH is the surface area of the cylinder. Then pi r square is the surface area of the top, because यहाँ लिखा है ना with top and bottom. With top and bottom. So pi r square for top and the other pi r square is for bottom. So 2 pi RH plus 2 pi r square, that has to be equal to 24 pi. Equality constraint है यहाँ. We have an equality constraint and there is no inequality constraint. Not given in the problem, but we know that neither the radius nor the height can be negative. Radius cannot be negative, height cannot be negative. So R and H has to be greater than or equal to 0. They cannot be negative. Okay. So this is the problem formulated. It is a constrained optimization problem and it is a non-linear optimization problem because of R square term, because of R square multiplied by H term. Even in constraint, you have R multiplied by H. Another term is R square. So every term is non-linear. And every term is non-linear. The problem is non-linear. But remember that I have already said for a non-linear problem, it is not necessary that every term should be non-linear. यहाँ पे है, लेकिन जरूरी नहीं है. If I have already said that if there are 100 terms in all, out of those 100, 99 terms are linear terms. There is only one term which is non-linear. Still, the problem is, will be named as non-linear optimization problem. So this is an example of constrained non-linear optimization problem. Constrained non-linear optimization problem. And for this category of problem, again there are n number of methods available. Constrained non-linear optimization problem, random search method, complex method, Rosen's gradient projection method, generalized reduced gradient method, SQP, the most typical, most commonly used method for non-linear problem, SQP, sequential quadratic programming method. And again means n number of methods are available. There is a long list. So we have seen that there are two broad categories of optimization problem, linear problem and non-linear problem. Accordingly, the method is to be selected. A linear problem can be constrained or unconstrained. A non-linear problem can be constrained or unconstrained. Accordingly, the method is to be selected. And as I said, I am repeating and I will repeat it in tomorrow's session also that nowadays you need not bother that see, there are 10 methods available to solve my problem. I am not interested in studying those 10 methods. My problem is different. I am doing research, I am doing PhD or I am doing post PhD research. My problem is entirely different. My problem is an electrical engineering problem related to transmission network, related to say some other thing, MPPT, maximum power point tracking. Why at all I should go for this, studying these methods? So yes, very true. You need not go through the methods. There are n number of methods, but nowadays, as I said, what is important is formulation of problem. Solution techniques are available. You can very easily get the solution. Softwares are available. You can get the solution. You can write a small program and you can get the solution. So formulation is important. Coming to, so broad categories are linear and non-linear. With that, coming to this, optimization in its broadest sense can be applied to solve many general or many engineering problems. It can be applied to solve many general problems, many engineering problems. Let's see some examples very fast because we are approaching to end. Hello. Someone wants to ask something? Okay, shall I continue or?
Yes, sir. You may continue. We will take the difficulties at the end of session, sir.
Yeah, I thought that there is some. I heard somebody speaking, so I thought that someone wants to ask some question. Okay.
No, no, sir. No, sir.
Okay, thank you. I'll just continue for some, say, few minutes more. I'll try to take some examples from different fields of electrical engineering. Say from the field of communication, we have just now seen this example. This is an example of optimization in the field of communication. We will not read the problem entirely. I just want to say focus that yes, optimization is applicable in every field and hence it is applicable in every field of engineering and hence it is applicable in every branch of electrical engineering, may it be high voltage, may it be power system, may it be electrical machines or may it be any other subject of electrical engineering. Communication very much related to electrical engineering. This is an example in the field of communication. Power electronics. there are so many people who have worked on this particular problem, same problem. So many people who have worked on this particular problem, and still many researchers are working with this problem. They are trying to devise new and new method to solve this problem. To find the optimum value of switching angles of power devices. Power devices may be thyristor, maybe IGBT, or maybe anything. So find the optimum value of switching angles of power devices so as to minimize the harmonics in multi-level inverter. So the aim is to design a multi-level inverter. The aim is to design a multi-level inverter, and the constraint is that the harmonics should be minimum. Harmonics are to be minimized. A very typical example. Many researchers have worked, many researchers are still working on this particular topic. So an example from the field of power electronics. Very typical example which we have come across, every one out of us. When we studied network analysis, we have come across maximum power transfer theorem. If you read this sentence completely, this basically deals with maximum power transfer theorem. Trying to maximize the power absorbed by the load under the given situation. So that is maximum power transfer theorem. An example from network analysis. Electrical machine design, if I say, or you take any, I am taking 3, 4, 5 examples. I could have taken the examples from structural engineering, from automobile engineering, but as the topic is related to electrical engineering and it is STTP for electrical engineering faculty only, I have taken the examples from electrical engineering. That to 3, 4 fields only. Electrical machine design. Design a 3-phase induction motor for maximizing the efficiency, or for minimizing the weight, or for best power factor, or ... maybe you can think of some other objective, but the aim is to design a 3-phase induction motor. So again, an example from the field of optimization. Electrical machine. Application of optimization in electrical machines. In this particular case, those who have taught machine design, they must be knowing that there is a long list of design variables: diameter of stator bore, length of stator bore, number of stator slots, rotor slots, specific magnetic loading, specific electric loading, and so many things. So many variables. There are some design variables, there are some control variables, and there are many constraints. You have to design for face-to-face 230 volt, 50 hertz frequency. Specific magnetic loading must be in the range 0.3 to 0.65. Specific electric loading should be or must be in the range 5,000 to 45,000. The number of rotor slots should never be equal to number of stator slots, and all that, to avoid magnetic locking. And so there is a long list of constraints. Taking all these into accounts, you can design a problem, frame a problem, and then go for the solution. This is related to machine design only. Now let's see an example very fast from the field of agricultural engineering. And in tomorrow's session, we will see how to solve this problem. It is not that why we are taking agriculture problem. In the same way, you can solve electrical engineering problem if the nature of problem is same. If it is linear and constraint, this is a linear constraint optimization problem. What I wanted to show here is that yes, optimization is applicable in other fields also. This is general. Farmer, agriculture field. Farmer is having 1,000 acres of land in which the farmer grows corn, wheat, and soybean. The profit contribution is given, and the cost of preparation of land per acre and number of man days per acre is also given. You have to find out the amount that the farmer can spend. That is also given. 1 lakh rupees for preparation of land and 8,000 man days. The question is, how many acres should be allotted to each crop so as to maximize the profit? Maximizing something, optimization. So an application of optimization in the field of agriculture. Likewise, you have typical applications. I have named this application. This is a transportation problem. A company is having 3 factories, let's say manufacturing air conditioners, and factories are located at Amravati, Mumbai, and Ghaziabad. And the warehouses, the destinations, the godowns are located at many different places, maybe 10 different places. How many units, how many refrigerators should be transported from Amravati to those destinations, from Ghaziabad to those destinations, and from Mumbai to those destinations, such that the requirement of destination is fulfilled, but the objective is to minimize the transportation cost. Total transportation cost should be minimized. So, a problem from the field of transportation. There also it is applicable. And I will come to a very interesting example now. The captain of a cricket team has to allot 5 batting positions to 5 batsmen. The average runs scored by each batsman at these positions are as follows. And these average runs have been obtained from the previous matches. Previous matches, those Dhoni, Ganguly, Dravid, Lakshman and Tendulkar have played. If Dhoni is sent as opener and that to facing end, which is called position 1, average runs scored are 40. Dhoni is sent as opener, but not on facing end, but running end. Average runs scored 40. 1 down, 35. 2 down, 25. And 3 down, 50. Likewise, the data for Ganguly, Dravid, Lakshman and Tendulkar is given. This is the data. Just to create interest, I have taken the name. They have nothing to do. इसका वास्तविक लोगों से अगर कोई संबंध हुआ तो वह केवल योगायोग समझा जाए. Dhoni, Ganguly, Dravid, Lakshman, Tendulkar, these are the average runs scored. The problem is find the assignment of batsmen to positions which would give the maximum number of runs. What is the aim of the team manager or the team captain? That the team should score maximum number of runs. When going for batting, the team should score maximum number of runs. And for that, the captain and manager, they have to decide, the captain and coach, the manager, they have to decide that out of these 5 batsmen, 5 specialized batsmen are there. It has been decided to have only 5 batsmen as specialized batsmen. So there cannot be 6. Okay. So out of these 5, who should be sent, who 2 should be sent as openers? And out of those 2 openers, who should be sent to facing end and who should go to running end? Who should be sent 1 down? Who should be sent 2 down? Who should be sent 3 down? This is a problem, assignment problem. This problem can be very easily solved by Hungarian method. जो क्लास को मैं पढ़ाता हूँ उसमें मैं हमेशा ये प्रॉब्लम सॉल्व करता हूँ. Hungarian method can be used to solve this problem very easily. Within 5 minutes, you can get the solution. Now, the problem can be extended. Now, if another batsman, IPL matches ho rahe hai, we found that there is another batsman, Kohli, who is playing very fine. And the average runs scored by this particular batsman at different positions is 45, 52, 38, 50 and 49. The question is whether Kohli should be included in the team. First question, whether Kohli should be included in the team. That is first. If yes, who will be replaced by him? Because the constraint is that I can have only 5 persons, only 5 players as batsmen. I cannot have 6. So the list which I have shown in previous slide, already having 5, now the 6th person has come. If at all, the answer to the first problem is yes, Kohli should be included in the team. The very next question is who will be replaced by him? I mean, out of the 5 previous shown in the previous slide, who should be taken out of the team? And once it is decided that XYZ person should be taken out of the team, the very next question is what will be the new batting position? It is not that, let's say, Dhoni earlier have got position 1 and now you are saying that Dhoni will be replaced by Kohli, so Kohli ko 1 number pe bhej do. Nahin, you will have to solve the problem again. There will be new assignments. So this makes you clear that yes, optimization is applicable in games also. Everywhere optimization is there. try to minimize something, it is optimization. You try to maximize something, it is optimization. So with this, I will conclude my today's session. If you want to ask anything, if anybody, any participant wants to ask anything, can ask. I will try to answer because the organizers have introduced me as a master of optimization, but I say, no, I'm not master. I'm just studying, I'm just learning optimization. There are many more things. I know only very, very small things related to optimization. So it is not necessary that I'll be able to answer your question. I'll try to answer your question. And if not, then I'll go through the books and then afterwards I will answer your question. So now if you want to ask any question, you can put your question or you can ask even in tomorrow's session. Thank you very much.
Thank you very much, sir, for a wonderful session. If participants have any queries, then they can ask.
Say after tomorrow's session, I'll be giving my mobile number, my email ID also. So afterwards also they can discuss with me if at all they want. So madam,
If
I think
participants have any queries, then they can ask.
we can conclude. There is no question. So, or anyway, if you want to continue the session for 5 minutes more, no problem.
Okay. So first, I am very much thankful to our today's resource person, Dr. P.P. Bedekar, sir, for sharing his knowledge about optimization. Sir has given the wonderful examples of optimization, which are very much useful in our day-to-day life. Sir, we will definitely implement all these things to optimize each and everything. So thank you, sir, once again. We are going to start our tomorrow's session at 9 a.m. sharp. Tomorrow's session will be continued by Dr. P.P. Bedekar, sir, which is on overview on popular optimization tools and techniques. So I request all the participants to join the same on time for smooth conduction of the program. So once again, thank you to all the participants for their presence. And with the permission of chairperson, I declare today's session is over. Thank you.
Thank you, madam.
Thank you, sir.
Okay, madam, exit करतोय मी आता.
Yes, sir. Yes, sir.
Okay.